Three blocks are located on a horizontal frictionless table. They are connected by a massless cord as shown in the figure and pulled to the right. The masses of the three blocks are M1 equals 8 kilograms, M2 equals 34 kilograms, and M3 equals 15 kilograms. The pulling force is equal to T3 equals 28 newtons. What is the acceleration of the system? To find the acceleration in a system like this, we can use an equation, which is acceleration is equal to T3, so the tension in the third rope, divided by the sum of all three masses that it is pulling, so M1 plus M2 plus M3. So in the problem they told us that T3 is equal to 28 newtons, M1 is equal to 8, M2 is equal to 34, and M3 is equal to 15. So the sum of the three masses is equal to 57. So now we can put this into the calculator and find our acceleration. So 28 divided by 57 is equal to 0.4912 meters per second squared for the acceleration, or if you wanted to write it in scientific notation, 4.91 times 10 to the negative 1 meters per second squared. So this is the acceleration of the whole system. The second question asks for the tension in rope 1. So we can use the same equation to solve for this as we did in the previous problem. So that equation was A equals T3 over M1 plus M2 plus M3. So in this problem we're not solving for T3, we're solving for T1. So we can substitute T3 for T1, and we can also take out M2 and M3 because the first rope only pulls mass 1. It doesn't pull mass 2 and mass 3. So we only have to write which mass it's pulling. So we can rewrite this equation. The acceleration equals T1 divided by M1. So in the last problem we figured out that acceleration is equal to 0.4912. We have to find T1, and the mass 1 is 8 kilograms. So we can multiply 8 over to the other side. T1 is equal to 8 times 0.4912, and we can put that into the calculator and get T1 to equal 3.9296 newtons as the tension in rope 1, or the tension in the rope pulling mass 1. So what is the tension in rope 2? We can use the same method. The acceleration will be equal to the tension in the second rope divided by the sum of the masses that the second rope is pulling, so M1 plus M2. So acceleration is equal to 0.4912. So T2 divided by mass 1 plus mass 2, that's 8 plus 34, or 42. So we can multiply 42 over to the other side to separate T2. So T2 is equal to 42 times 0.4912, and we can put that into the calculator to get T2 equaling 20.6304 newtons.